Shake Table Lab by Rhys and Jake North. First, we did a preliminary sketch of our tower. This sketch includes our measurements and support structure. When we started building, we secured the main supports to the base for added stability. These supports had 2 straws for extra strength. Next, we built the bottom structure of our tower. Then, we decided to use V-shaped cross supports in order to provide stability with a small number of straws. We built the structure for the top of our tower. When we realized that we had extra straws, we decided to use more straws to reinforce the cross supports by creating more triangles. This idea was successful, and our tower is much stronger. Rhys and I finished our tower by adding a decorative roof. We used multiple strips of construction paper to decorate our tower, and put all tape on the inside where it could not be seen. We also used extra straws to add a pillar on the inside of the tower that would help to support it. After we finished construction, we measured our tower. Most of our goals were accurate, within 1.5 centimeters, except for the width of the base. The base was wider because we decided that a wider base would do a better job supporting the tower, and the tower was taller because of the decorative roof. My team's tower was successful in static testing and was able to hold 2 sandbags on each floor. The tower did not show any weaknesses in this test and was able to support the weight easily. My partner Rhys and I strengthened our tower by using 3 straws to support each wall and running a central support column through the middle of our tower. This was successful and provided the maximum number of triangles on the sides with 3 straws each. Our tower's strongest parts were the base supports, which were 3 straws thick for strength and were attached to the base by anchors. On our tower, the weakest part was the first floor. It was held in place by a minimal amount of tape, and the middle was supported by 1 beam. Our team used tape to secure the joints of our tower and attach the floors and decorative roof. We did our best not to use too much tape. Pictured is the one joint where the most tape was used. We made our floors out of brown construction paper. The edges of the floors were wrapped around the straws and secured with tape to provide strength. These floors were attached to the central support column in the middle. Our tower started to shake as soon as 8 sandbags were placed on it.
Here's your earthquake.
The tower was able to hold 10 sandbags, but collapsed while trying to support 12. During shake table testing, I took a screenshot of our XYZ graph. On the graph, the x-axis represents our tower moving from side to side, the y-axis represents our tower moving backwards and forwards, and the z-axis represents our tower moving up and down.
Hi, my name is Rhys. During shake table testing, our tower supported 10 sandbags and fell while trying to support 12. Our building failed when the cross supports detached from the tape, which resulted in the tower falling. I could have secured the cross supports with more tape to make the building much more stronger. In addition, adding more supports onto the first floor would have helped. During the building process, I learned that cross supports along the sides of a building make it much stronger and more earthquake-proof. Also, I learned that triangles are the strongest shape. I enjoyed collaborating with my partner and learning about earthquake-proof buildings. I also enjoyed shake table testing. Thank you.
Hi, I'm Jake North. During shake table testing, our tower supported 10 sandbags but collapsed at 12. Our building failed at a joint of the cross supports on the first floor because the weight of the second floor and the rest of the tower was all on it. The tape broke and the tower collapsed. If I could make any changes to my tower right now, I would probably add more supports on the first floor because this is where pretty much all of the towers collapsed. Something I learned about building an earthquake-proof building is that triangles are one of the strongest shapes that you can use, and I also learned that the first floor will likely be the weakest because it has the weight of all of the other floors on it. One of the main things that I enjoyed about this lab was collaborating with my partner, and I really enjoyed learning about building earthquake-proof buildings.